Section 12.7, Biomaterials. So a biomaterial is any material that has some biomedical application. So if you make this material and then you use it for medicine, it's a biomaterial. So sometimes you would use a material because a different material is not as suitable. Okay, to use wood or stone or metal might not be what you want to do, or it may. You may want a hip joint made out of some kind of a metal alloy, or you may want a synthetic material, and if you can design it so that it's adequate and long-lasting and doesn't get infected or doesn't infect the person, then it's useful to them, and that's what you would want to do. So you're using it in therapies, and you're also using it to diagnose things. Okay, so materials that would diagnose even a disease would be a biomaterial. So characteristics of them need to be that they're compatible with the body. That's biocompatibility. We'll look at that in just a second. It has to have physical requirements. So for instance, if you're going to put stress on it or whatever, it has to meet those. And chemical requirements. So it has to be in some ways suitable to chemical-wise as medical grade. So let's look at these one by one. Okay, so the first one is that they have to be biocompatible. They have to work with the body. The body can't be allergic to it. The body can't see it as a foreign invader and actually be bringing up inflammatory responses because of it. Okay, so the chemical nature of it and its physical nature is very important because the body itself is made out of chemicals. Everything is chemistry. So these chemistry interactions are important, and if you can make it so that it's inert and it's not causing problems, then it's more suitable to its task. Its physical requirements, okay, it might have to be really, really flexible or very, very strong. You don't want to take out someone's hip over and over again. It's a big deal. So you want it to have a certain rigidity. You don't want it to break at the places you want it to break. You want, for instance, part of that tissue to actually fuse to it. So like you actually want to make it so that it's fusible. So those physical, what are you using it for exactly? What is the situation biomedically in that area that you're going to use this device or implant or whatever for? And so there's all kinds of different physical requirements. And then chemical requirements, okay? You can't poison someone with your heart implant, and it can't break down. So if your body conditions are harsh to this material to where it actually breaks down, then you're poisoning yourself with it. That's probably not a good idea. Okay, so here's an example. This is a heart valve. Okay, so these are made out of polymers, and so this is an aortic valve. Like the top of the aorta can sometimes degrade. Okay, so they don't want to break down the blood cells. So there's all kinds of things on it. You want it to not just pump like pumping water, but since you're pumping vital materials, you don't want it to be a problem to those. So you can't have complications that result from the roughness of the surface. So it has to connect to the body tissues. The body tissues have to graft into it, incorporate it into it. Okay. You can also have vascular grafts, which would replace a certain part of your arteries. Like you can put them in, and a lot of these, so Dacron and polytetrafluorine ethylene, how about that for a big long thing? These things are capable of coming very near the heart and not causing a lot of problems. Okay, and there's still problems. Like you might have this version of this heart valve may still have problems. There might be blood clot risks or other things involved with this particular model that, as it's working the best, I mean, it's saving people's lives that would otherwise have died, but researchers are still tweaking it, trying to make it more and more useful. And sometimes you need to throw out one model and replace it with something completely new. Okay, so here is that that dacron that I was telling you about. So these capillaries can actually grow into it. So it allows it to fuse so that it will become a permanent part of that person. Okay, and then you can make artificial tissue, so lab-grown skin and other things like that.